PowerPoint, there was a picture of a manhole cover. And when you open up a manhole, many times you will find a device like this called a closure. This closure is made by 3M and it's made specifically for fiber optics. And a lot of times as you're driving around town, you'll see, trailers with a lot of men around with hard hats on, and what we kind of like to do, we'll ventilate the manhole, and we'll pull the cable up out of the manhole, and we'll put this in an air-conditioned trailer. And a lot of this will be taking place inside of a trailer. And this closure is designed to keep water out, keep insects out. It's sealed, and let's get into it. I'll show you how to do that. You take a device like this called a speed wrench, and you just put up the bolts, just like this, go around, and one of the things as well, some companies do this, we actually don't, but a lot of people pressurize these, so as you're taking these bolts out, the air pressure will come out and just kind of blow some of the stuff that's in there out. You kind of want to avoid that if you have a pressurized closure. It's pretty messy. When you open the closure, you will find in various stages of condition. This closure, how it's made. We have the fiber optic cable coming into it, and when you prep the cable, you cut back on the sheathing, and if you look down here, you'll see these plastic tubes called buffer tubes, and within these tubes lies the fiber. And we dress the fiber out. There's certain lengths that we use to dress the fiber out, and this is what a fiber tray looks like. And as you can see, there's varying fiber counts. Fiber itself is color-coded with a standard telecommunications color code. Blue would be your first fiber, and that's blue. You'll have orange, green, brown, slate, white, red, black, yellow, and violet. And as you can see, these fibers are very small. About the size of a human hair. And when we go into the splicing demonstration, you'll see exactly how small they are. Splicing fiber, one of the most important things with splicing fiber is cleanliness. Fibers have to be clean, and we have a lot of materials here to do that. We have alcohol, we have chem wipes, and this is our splicing machine right here. And in a nutshell, what it does, and you'll get to see this, it takes the two fibers, and this is a fusion splicer. So what it does is it brings the two fibers together, optimizes the loss of light going through it, and it fuses these fibers together with an electrical arc. And you'll see this whole process with this splicing. Now to begin with, what we have to do, we have to take our fiber, we have to strip the cladding off. Again, this is our blue fiber. Cladding is very important in a fiber. A fiber is made of glass, and the cladding actually protects it and it makes it flexible and keeps it from breaking because it can be very brittle. So strip the cladding off, as such, and take an alcohol wipe and clean it just like this. This is called a cleaver. This cuts the fiber. This is very important because the cuts at the ends of the fiber they have to be as straight as possible in order to get the optimal loss going through the fiber. You line the cladding up to, if you can see the number 12 there, probably kind of hard to see. Lay this down, that's 1. Slide this through 2, 3. As you can see, the fiber is cut. Now you load it into the machine. Like this. Again, very hard to see this sometimes. And by the way, you should never look into a fiber, and that happens a lot. Sometimes they break. And that's just what happened here. This fiber broke. So we're going to have to do it again. And very quickly, we'll just strip the cladding off. Sometimes that cladding takes kind of hard to get the cladding off. And each fiber is different. Each fiber manufacturer is different. Even though Corning makes most of the glass for fiber optics, each manufacturer with their cladding makes things a little different. And sometimes it's difficult to get that cladding. Lay the fiber in there. Lay it into the chocks. Put that down to hold it in. And then we'll take another fiber. And you do the same thing to it. Strip the cladding off, just like this. Alcohol swab. Cleaver. And you lay it into this side. And as you see, the core of the fiber is the white line in the middle, and the outside of the fiber is what you see there. It's all nice and clean. You'd be able to tell if there was dirt on it. And it's lining up the axes. It's getting the optimal alignment there. And it will be fusing here in a second. A lot of times it takes its time doing this. Again, it wants to make it aligned as good as possible. And there's the fusion right there, and it fused it. And it gives you an analysis of the splice, which is a .02. It's a good splice, okay, according to the splicer. But the way we measure loss is we have a person on the end of the network, usually, and they're usually miles away. He's running a device called an OTDR, which is an optical time domain reflectometer. And we'll be looking at that here in a second, and we'll kind of get an idea of exactly what this splice loss is. And this is a field splice right here, and this is what people do out in the field. And they'll do the splicing, and then someone on the end will measure the loss. If it is not good enough, we'll have to break it and splice it again. One of the things that I was mentioning when we were splicing is splice loss. And splice loss is something that you don't want to have in your fiber optic network. You want to minimize that. An acceptable standard for us is a 0.2 dB splice loss per splice. Whereas the splicer will tell you what the splice loss there is. The true measurement of splice loss is done with a device called the OTDR. OTDR stands for Optical Time Domain Reflectometer. This device measures OTDR. Also, this is the fiber optic technician's friend. This device will help you find a broken fiber. This device will measure optical loss, and you can also measure power meter readings and various other readings with this device. What we have here is we have a setup here. Each one of these boxes is a kilometer of fiber optics. And we have them connected together so that we can see an optical loss in that connection. And right now we have this running in real time. What the OTDR does is pulse light out. And so that's what it's doing right now. I want to show you what splice loss does. Splice loss actually attenuates your fiber. And like I said, attenuation is bad. When I pick up one of the patch cords here, and this is a very common patch cord that we run in all of your, all fiber optic networks. This patch cord needs to be run in such a way that it's free of kinks and free of an environment where it's going to be bent or anything. And if you look at the machine here, when I just bend this fiber, you will see just what a bend will do to your splice loss. And you see that reading go way up. And of course, the lower the reading, the better. So you want to minimize optical loss. Another thing that also causes loss is dirt on a fiber. And in a fiber optic environment, cleanliness is very important. Like what I have here, this is called a fiber cleaner. And this here is called an optical fiber scrub. And what you do is you will take one of your patch cords and put it in the camera here, and it will show you, whether the fiber is dirty or clean. And that is a very clean fiber. You can see the core there, which is the white dot, and that is a clean fiber. That is what you want to achieve. I'll show you a dirty fiber here, and just sticking your finger on it can cause lots of dirt in the fiber. And as you can see, the dirt on the fiber there, and that will affect your phone call, that will affect your internet data. That has a bad effect on a lot of things. So what we would do, take our fiber cleaner and swab this fiber and put it into the camera, and you have a clean fiber once again. And in a fiber optic environment, cleanliness is the only way that you're going to achieve good quality transmission. Anyway, thank you very much. That is my presentation, and I hope you enjoyed it. Thank you.